see, we measure things all the time. That's how we compare one thing to another. Measuring things is how we understand the world. And especially, it's how we understand our place on it. Measuring things allows us to figure out how long it takes to get from one place to another. If we didn't measure things, everything we build would fall right down. The better we measure, the better things fit.
Hey, Mrs. Simonson here. We are working with the metric system this evening, and we have two objectives. The first is to estimate measurements using benchmarks, and the second is to convert measurements to solve problems using ratios. So first, let's think about the metric system. It's the more user-friendly measurement system in that whether we're measuring the length, the capacity, or the weight of something, we use a base measure. And then we assign prefixes to that measurement to show how much larger it is than the base or smaller. And a mnemonic device to help remember those prefixes is King Henry died by drinking chocolate milk. A kilo, a hecto, a deca, then the base, deci, centi, milli. So a kilo is 1,000 times the amount of a base, while milli is 1,000th the size of the base. When we estimate the measurements in the metric system, we use what's called benchmarks. We taped this benchmark chart into your vocabulary section of your notes, and I want you to take some time to just review it before moving on to the next slide. Press play when you're ready. All right, let's say I want to measure the length of our whiteboards that are on the west walls of our classrooms. I would either use millimeters, centimeter, meters, or kilometers. Well, the millimeter, the benchmark, is the thickness of a dime. That's a pretty small measurement to try to measure the length of a whiteboard. Centimeters are the width of my pointer finger. Though it can be done, it's not the most efficient to use the centimeter to measure the length. Kilometer is about 9 football fields. That's far too large. So I would probably use the meter. And we think about the length of the meter. The benchmark is the height of an average kindergartner. So you'd want to think about how many kindergartners would be that bottom length. And we could estimate that it would be 2. All right, now let's think about the coffee mug. How much of liquid could a coffee mug hold? Well, we've got millimeter, liter, or kiloliter. A millimeter is an eyedropper amount, a pretty small amount, but it could be done. A liter is a large water bottle. That would be far more than the coffee mug. And a kiloliter is 8 large trash cans, which would be far too much for the coffee mug. So we're going to estimate that we would use the milliliter. And when we're thinking about how many of the millimeters would we need, I would say maybe 50. Okay. Let's think about the bike. The weight of a bike, we could use milligram, gram, or kilogram. Dash of salt, small paperclip, or a textbook. Well, it should be pretty obvious that we're going to probably use the textbook for the bike. Now, when we think about, about how many textbooks, this is where it can get a little tricky and answers will vary. I would say about 10. All right, now I want you to practice. I want you to estimate the measurements for a Band-Aid, a bottle cap, and a TV. And I gave you some targets. All you need to do is match the object with the appropriate unit. Press play when you're ready. One other major skill you need to know when working with the metric system is how to convert within that system. And it actually pulls from some previous work we've done with proportions, because you can convert in the metric system using proportions pretty simply. Let's say I have 200 centimeters and I want to convert that to meters. The first thing I need to do is set up a proportion. So I'm going to say 200 centimeters is to x meters, x just standing for the unknown, as, and the other half of my proportion is always going to be the unit rate. And if you look at the vocabulary portion of your notes, we've typed up all the unit rates you're going to need to use. In this case, The unit rate for centimeters and meters is 100 centimeters is equal to 1 meter. Now that I've set up my proportion, the next thing I need to do is use cross products to solve it. So 200 times 1 is equal to 100 times x. 200 times 1 is 200. 100 times x stays the same. Now to isolate or get x on its own, this is where we divide it by the number being multiplied by x, and in this case that's 100. 100 divided by 100 is 1. 1x is equal to 200 divided by 100 is 2. So 200 centimeters is equal to 2 meters. I want you to solve problems 4, 5, and 6 in your math notebook. Remember to use your unit rate chart to help set up the proportion, and then use cross products to find the missing term. Press play when you're ready to see the work. Conversions can help us to solve many problems. Let's say I have this problem. Mr. Hausman rode 2 kilometers on his bike. Mr. Hansen 3,000 meters on his bike. Who rode further and how much further? The first thing I need to note is that I have 2 different units here. I have kilometers and meters. And that question is asking me to compare them. In order to compare them, I need them to be the same unit. So I can either change Mr. Hausman to meters or Mr. Hansen to kilometers. It doesn't matter which one I use. Let's exchange Mr. Hausman's 2 kilometers into meters. So I'll say 2 kilometers is to X amount of meters as, and this is where I'll use the unit rate, 1 kilometer is equal to 1,000 meters. Now I can use cross proportions to find this missing term. 2 times 1,000 is equal to 1 times X. 2 times 1,000 is 2,000. 1 times x, divide both sides by 1, x equals 2,000. So Mr. Hausman riding 2 kilometers is the same as Mr. Hausman riding 2,000 meters. So the question is, who rode further? Well, that's Mr. Hansen. And how much further? 1,000 meters. Go ahead and solve this practice problem about Ms. Schrader and Mrs. Hiley in your notebook. Let's number it as problem number 7. And press play when you're ready to see the answer. So tonight we worked with the metric system, and we worked in 2 areas. First, we estimated measurements using benchmarks, and then we learned how we could use ratios to convert measurements to solve problems. At this time, you could either review any portion of this video or try some practice problems on your own. When you feel ready, take your quiz at Schoology. See ya!